Integration of polynomials. This is an AS level, which is the first year of A level, module C1. I'm going to start with a recap on integration, which is going to go through all the skills needed, all the things you should remember when integrating. And then we've got 14 questions, as you can see here. You can click on any one of these questions and it should take you to that question on YouTube. And at any point, if you want, there's an index button here which will take you back to this page, so you can then access to any of the questions. You can see the type of question, what's being asked. I've cut and pasted the main part of the question into these boxes, so you've got an idea of what polynomials are going to be integrated in each question. Okay, let's move straight on to the recap. Okay, so recap on integration. To start with, we'll look at the types of nomenclature that is used to describe some integration. So we've got our typical integration symbol, this symbol here, which means to integrate, and then you have something. In this case, we're only dealing with polynomials, so some power of x that we have to integrate with respect to x usually. It doesn't have to be x; it could be any letter. As long as this letter here was the same as this letter there, that shows you that that's what you're integrating. So this is your standard integration symbol. This means to do the integration. Integration is the opposite of differentiation. So if you know how to differentiate, you should know how to integrate, because you're doing the inverse, the opposite. This is the other way of writing this question. This question has been written as a differentiation. So dy by dx. This is the function after you differentiated. So if you want to get back to the original function y, then you need to integrate this function that's dy by dx, because that undoes the differentiation and does the integration. So we end up starting with the symbol for differentiation, but essentially we're going to have to integrate this polynomial. And then we've got the function notation version, which instead of just writing dy by dx equals this, we've got f dashed of x, which is the same thing. F dash means the differential of a function of x, and we want to get back to f of x, and again we're going to have to integrate that function with respect to x to get back to the original f of x function. So f dashed of x is the differential of a function, so when we're integrating, we're going back to the original function. Okay, so that's the basics with how things are written. When you're integrating, the key thing to remember is the opposite of differentiation. So if you know how to differentiate, like I said, you can integrate. So when you've got a power that you want to, you've got a function of something, say x squared, and you're told to integrate that. What you're doing is essentially this is increased by 1, so you're taking it up to x cubed by adding 1 to the power, and then you've got to think about what would you've done if you differentiated this. When you differentiate, you take this power and it comes down to here, and then this decreases by 1 to get the x squared. But if this number comes down to here, we'll have 3x squared when we differentiate. So we need 1x squared here, because it's just x squared on its own. So what we need to do is we need to divide by this number, this 3. So we end up, the easiest way to do that is to make this 1/3 of x cubed. So when you're checking your integration, you should always be thinking about, well, what would happen if I differentiated this? So I get 3 lots of x squared, and you've got 1/3 in front, so 3 lots of 1/3 cancels out to just leave you with x squared. So the process of integration is to figure out what it's going to in terms of a function of x, and then to undo any consequences of differentiating that number when it comes down. Essentially you just divide by that number, or multiply by the reciprocal, which is in this case 1/3. Okay, so what things cause people problems? Well, things like integrating the square root of x, that causes a problem because it doesn't have a number here, so we need to be aware that that's just x to the power of 1/2, and then we just carry on in the normal way by adding 1 to the power, so we get 1/2. It's not really the done thing to write to the power of 1/2, so we add 1 in terms of 2 halves, which makes it 3. So 1.5 written as a top-heavy fraction is 3/2. And then again, to undo what would happen when we differentiate this would come down to make 3/2, we need to divide by 3/2, which is the same as multiplying by the reciprocal, which is 2/3. And that idea of reciprocals is very useful when dealing with fractions. You just turn the fraction upside down. Oh, and don't forget, on all these questions, I should have done this is very naughty of me, when you integrate at the end, if you've not found a definite integral, so you've not found an exact value, there's always a constant term, because when you're integrating, when you're differentiating, any constant term disappears. So when you're integrating, there could have been a constant term, so you have to add one in. So a sort of not random, but just a number that we call usually C. It doesn't have to be C, but that's what the sort of standard notation for that is. Okay, other things that cause problems, well, integrating 1 over something, so like 1/x² dx. We need to be aware with our power knowledge or indices knowledge that this is the same as the integrating of x to the -2, 1/x². The 1 over, it gives you the negative power of x², so x to the -2 dx. And when we do that, we need to add 1 to the power to make it x to the -1. Realize that when we differentiate that, we times by -1. So the only thing we need to do here is divide by -1, which is just put a minus sign in front. And don't forget your constant. Okay, it may seem a bit silly, this constant. You will lose a mark on any integration question if you haven't, or some questions you have to work out this constant, so it's quite important to have it there. But if there's not a constant to work out, you must put it there, otherwise you'll lose at least 1 mark. Okay, so that's dealing with a few of the basics. We're going to see a lot of examples of different functions to integrate. When you have multiple polynomials, so you've got this with multiple values of x², then you just do each one individually. Each one stands alone, so you can do them each individually. So you treat them as 3 separate integrations, but only have 1 constant term. Okay, and then you have the other thing that we need to be aware of is if you have to integrate something and you're told a coordinate, so integrate, say, x² again dx, but we know that our curve's going to pass through 2, 3, for example. Then when we integrate this, we get what we had over here, 1/3 x³ plus a constant. So that's our equation of the curve that gave us this value. And that's usually where this notation comes in. So you're saying dy by dx, the differential of a curve is equal to x², for example. What is the equation of the curve if it passes through 2, 3? Now this constant can allow this curve to pass through any number. So what we need to do is put these 2 values in for x and y. So we put y is 3, x is 2, so 2 cubed. And then we've got to work out this number, whatever that is. So we end up with 3. 2 cubed is 8. 1/3 times 8 is 8/3. And then we can take that away. 8/3 is 2 and 2/3. We take that away from 3. We end up with 1/3. So c is 1/3. So that tells us that the equation was y equals 1/3 x³ plus 1/3. Okay, so when we see a coordinate, it means that we are going to be working out this constant term we've integrated. So that's sort of a clue to what to do on these sort of questions. Okay, so that's the recap for you. Let's get into some questions. Okay, here we go. Question 1. I'm going to start off with a full-on complicated question. I'm not going to mess about. So this is probably pretty much as hard as they come. There are a few variations that can make it quite tricky as well, but this is a pretty standard one of a 6-mark type question. Okay, we're given our question, so it's not obvious that it's an integration question in the format of a differential. So dy by dx equals this function of x when x is not equal to 0. The reason why it's put in this is because if x is 0, this is impossible to work out because you're dividing by 0. So they just cancel that out, so we're not worrying about those problems. So we've got a few clues in here. This section here is a clue. Try to find y as a clue. I mean, we'll keep determine its simplest form, which is just something we need to be careful with at the end. Cancel out any fractions, cancel down any fractions, and make sure there's no x's that can be cancelled in any one of the terms. Now this looks like it's a 2-term equation, but it's actually 3 terms, and I'll show you why in a second. So what we're trying to find is y. So to find y, we need to integrate this differential. So we need to integrate x to the minus x to the 3 plus 4x minus 5 all over 2x cubed dx. Now the reason why this is 3 is because this fraction is in fact 2 separate terms. You've got 2 terms on the top and 1 on the bottom. So to be able to integrate this, the easiest way to do this is to break it down into 2 separate fractions. So what we're really going to be doing is integrating the minus x cubed plus 4x over 2x cubed minus 5 over 2x cubed. Yeah, so it's 3 terms. Okay, I'm going to do each term separately. So I'm going to integrate each term. I'm going to integrate the minus x cubed because that's the easiest one. Okay, and that's going to go, so the rules are with integration we add 1 to the power, so the power of x becomes 4. Think about what would happen when I differentiate this. I get 4 in front of here, so I need to undo that by multiplying by a quarter. But I want a minus x cubed, so I just need to whack in a minus sign in the front there to make sure they have a minus when we've differentiated this into this. So when we integrate this, we need to have the minus there still. So that's the first one. Then we're going to integrate the second one, 4x over 2x cubed. Well, to start with, let's just cancel out any numbers. This 4 and this 2 cancels because 2 goes into 4 twice. And this x and this x cubed cancel. We've got x to the 1. A couple of things, you should be able to just you should be capable of cancelling x's in a fraction like this. So x to the 1 and x to the 3. So there's one of the x's going to cancel one of these 3 x's to leave us with, let's write that, it's going to leave us with, so we've got the 2, the x disappears because it's going to cancel with some of these on the bottom, so we've got to end up with that. Another way of thinking about that, actually, if we'll have a look up here, is if we think about the x cubed as being x to the minus 3, anything where there's an x power on the bottom of a fraction, that's a negative power of x, so we've actually got 2x over x cubed is the same as 2x times x to the minus 3, and that's x to the minus 1, and we know when we multiply in powers we just add them, so we've got 2x to the minus 2, which is what this is. And I would always suggest, if you have any fractions with the x's on the bottom, you change them into negative powers. So we're actually going to integrate 2x to the minus 2 dx, because then we can just add 1 to the minus power to make x to the minus 1. When we're going to multiply this, we multiply by the reciprocal of this, which is going to be, well, the reciprocal of 1 is 1, so it's going to be minus, reciprocal of minus 1 is minus 1. And then we've got this original 2 here, so we need 2 lots of that, so it's minus 2. So thinking about this, when this comes down and multiplied by the minus 2, that changes the sign to make it just 2. And the last one, the 5 over 2x cubed dx. I'm going to show you a little technique here that will help if you get not very good with fractions. It's probably best to take the fraction outside. It's actually minus this, but we can take the minus outside as well. So we've got minus 5 over 2, and then we're going to integrate what's left, which is just 1 over x cubed, and that's the same as minus 5 over 2 integrated x to the minus 3. X to the minus 3, we add 1 to the power to make x to the minus 2. Be careful not to make that minus 4 because we've got to go up 1. And then we've got to deal with this minus, so this minus and this minus cancel. we need to multiply by the reciprocal of this, which is a half, and 5 over 2. So we actually have minus 5 over 2 times minus a half, and those cancel to give you 5 over 4 x to the minus 2. Okay, so our y over here is equal to each one of these. So we've got minus a quarter x to the 4, and then we're going to subtract this 2x to the minus 1, and then we're going to add 5 over 4 x to the minus 2, and we need to add on a constant. Each one of these has a constant term, but when we combine them all it makes a new constant, so we just need the one constant term. Okay, we need to make sure there's no fractions we can't cancel down. I've done all the cancelling in the questions over here, so we don't need to do any cancelling, but make sure you don't have anything like 2 over 8 or anything like that, so you can cancel down. These negative powers can be left as negative powers, no problem with that. You could write them as, this could be written as 2 over x if you wanted, but it's much easier to deal with when it's negative powers, so I'll leave them as those. Now we're going to deal with this y equals 7 at x equals 1. So that's the reason for that is to find this constant term. So we've got the complete equation. So y equals 7 at x equals 1. We're going to bung those numbers into there. So at 7, that's what y is, minus a quarter times 1 to the power of 4, minus 2 times 1 to the power of minus 1, plus 5 over 4 times 1 to the minus 2 plus a constant. All these powers of 1 are just 1, so 7 equals minus a quarter minus 2 plus 5 over 4 plus a constant. Minus a quarter plus 5 over 4 is just 1, because 5 over 4 taken away a quarter is 4 over 4, which is 1, plus the 2, minus 2 plus 1 gives us minus 1. Take the minus 1 over the other side, becomes plus 1, so we get 8 equals c. So our final equation is y equals minus a quarter x to the 4 minus 2x to the minus 1 plus 5 over 4 x to the minus 2. I'm just taking this from over here, so that's the one we had before the c, and then we're just going to add on 8 onto the end because that's the constant term. Okay, so did quite a lot there. It's quite a very detailed question, very tricky question to get every component correct. But obviously there's lots of marks to be gained for each stage, so each one of these will give you a mark, and then there'll be a mark for substituting in finding the c and getting the final equation. Quite often people forget the c, so they put the 7 in here and then the 1's in here, and they end up having some strange equation that doesn't work because we don't have this extra constant on the end to make it work. Okay, but that's a pretty difficult question. We've done it for question 1. Hopefully the more you do, the better you get at these. So keep practicing with the next one. Question 2. Very similar to question 1. The notation is different. It's using function notation. The polynomial is much easier to integrate, but you still got to find the constant term by using the points. This giving the point is a clue to what you've got to do. And then you've got to find the value of f of 1. So when the function equals 1, when the x value equals 1, what's the function? But until you've found the whole function, you can't do that. This is worth 5 marks, so 1 less than the last question, possibly because it's just easier, a little bit easier. Okay, so we're trying to find what y equals. So we're trying to find f of x. F of x is equal to the integral of 3x squared minus 3x plus 5 dx. So we need to integrate each term, and because it's much easier, I'm just going to work through this. So x squared goes to x cubed. When we differentiate x cubed, we get 3x squared, which is what that is, so we don't need to do anything else to that, that's fine. Then we've got minus, and then x to the power of 1 goes up to x to the power of 2. When you differentiate that, that becomes 2x to the power, just 2x to the power of 1, which is just 2x, but we want 3. So we need to keep the 3 that was there originally, and then divide by the 2 that's going to come down here. So when we times by this 2, that gets rid of this 2 on the bottom, and and that will give us that value of 3. And then the 5 is going to go from, this is x to the power of 0, and it's a constant term, so that needs to go up to x to the power of 1, which is just x. And because that's power of 1, that's not going to change anything, so we just need a 5 in there. So when we differentiate 5x, we just get 5. Okay, so and then we need to add on a constant. So that was much easier integrating than the other one. We need to work out the point. So x equals 2 when y equals 10, or f of x equals 10. So 10 is equal to 2 cubed minus 3 over 2 times 2 squared plus 5 times 2 plus the constant. 2 cubed is 8. 2 squared is 4. 4 times 3 over 2, well the 2 cancels with the 4 to leave a 2, so that's just going to be 6. So 1.5 times by 4 is 6, and 5 times 2 is 10, plus the constant. So 8 take away 6 is 2, plus 10 is 12. So we've got 10 equals 12 plus c, so c is going to be minus 2. So we take the 12 away, we get minus 2. So that tells us that f of x equals x cubed minus 3 over 2 plus 5x minus 2. Now we've just got to finish off find f of 1. So f of 1 is when x is 1. So we've got 1 cubed minus, oh, I missed something out there, 3 over 2 x squared. See, I spot that. So 3 over 2x squared, so minus 3 over 2, 1 squared, plus 5 times 1, minus 2. So we've got 1, because 1 cubed is 1. Minus 3 over 2 times 1 plus 5 times 1 minus 2. So we've got 1 plus 5 is 6, take away 2 is 4, minus 1.5. 4 minus 1 is 3, minus 1/2 is 2.5. So f of 1 equals 2.5. Now, as I said, there's a much more straightforward integration, but the process is exactly the same as the previous question. Yeah, 5 marks. Question 3. This is our first of just the basic integration questions. It's still worth 5 marks though. So you still have to integrate 3 parts. 2 of them are really straightforward. This third fraction, this fractional power makes it a little bit complicated. But if we just write, I don't want to write it out again, but we'll write it out again. So we've got 3 terms that we need to integrate with respect to x. Start with this first term, so that x to the 5 is going to go up to x to the 6. We need to times by the reciprocal of 6, which is 1/6. Cancel that down in a second. You could actually, if you're thinking about it, think about what do I need to times by 6 to make 12, and it's quite nice, it's going to be 2, but we'll just put that in there for now. Some people like to put the fraction in. The next one, x to the 3, and again this is going to be quite nice, the 3's there already, so we don't need to do anything here. This 3 is going to come down here, which is what we want anyway, so we've got 3 times a third, which is just 1, so we just leave that. And this power, x to the third, add 1 to 1/3 to make 4/3, because 1 is 3/3. So 1 1/3, which is 4/3. Multiply by this reciprocal, so turn that upside down and multiply. So we end up with 3/4, and 4 lots of 3/4 is just going to be 3. And don't forget to put your constant term on the end. Let's tidy it up. So we've got 12 divided by 6 is 2x to the 6 minus x cubed plus 4 lots of 3/4 is just 3, x to the 4/3. What makes these sort of questions difficult is the fractional powers. They're the only real complicated things here, and to remember to put the constant on the end. That often costs people at least 1 mark. You're getting 1 mark for each section, and 1 method mark for showing that you know one correct method of integration. So you integrate any one of these correctly, it gets you method mark, 1 for each of those, and 1 for the fully correct answer. Question 4. Another sort of standard question. In fact, a lot of these questions will be fairly standard, but this is quite nice. X squared's x and a number, so a nice polynomial, nothing complicated. You're told about an equation y equals f of x, passes through the point -1, 0, so that's your clue that you're going to have to find the constant. You're told that the differential of x is this, so we want to find f of x. So to find f of x, we need to integrate the differential, so we need to integrate 12x squared minus 8x plus 1 dx. The 12x squared, the x squared goes to x cubed, so we add 1 to the power. Think about, I'm going to actually go straight to the number here because this is quite a nice 12 here, so 3 times what is 12? So this is going to be 4, because when we differentiate this, 3 is going to come down here, multiply by this 4 to make the 12. And again, I'm going to do the same thing here. You should be able to spot these things after a while. So x to the 1 goes to a 2. 2 times what is 8, or 2 times 4 is 8. And then the last term, the 1 just comes from x. Differential of x to the power of 1 is just 1. And don't forget to put your constant term on the end. So this is our function f of x, which is what y is going to be equal to. Now we just need to put x equals -1 when y equals 0. So 0 equals, can we get that from the coordinate? That's the x and the y coordinate. We know this passes through that coordinate, so we can put those in there. So we've got 4 times -1 cubed minus 4 times -1 squared plus -1 plus the number we're trying to find, the constant. So -1 cubed is -1 times 4 is -4. -1 squared is 1 times -4 is -4 plus -1, so we're going to take away 1 plus our constant. So we're taking away 9, that 9 goes over to the other side to become +9, so the constant equals 9. So that tells us that y is equal to 4x cubed, we're just taking this original equation over here, minus 4x squared plus the x plus the 9 that we just found. And then we have a complete answer there. A really nice question, a really bit of a gift to the question. The integrating is very straightforward. Don't forget your constant term, and then you should be able to find the constant term when you put the numbers in to get the full equation for 5 marks. Question 5. So we've got 3 terms we need to integrate, straightforward integration. Let's do each term one at a time. So the first term, x squared comes from x cubed. Okay, so the 6 in front is going to come in from 3 times something. Well, that's 3 times 2, so that's going to be 2x cubed. So 3 times the 2 gives us 6. Take a 1 off the power gives the 2. So as always, checking you're integrating by differentiating to make sure you get the same thing. Now this second term, a little bit tricky with the 2 over x squared, so I'm just going to show that one separately. So we're going to integrate 2 over x squared. I'm going to show you a technique that's going to be useful in the long run if you want to focus on the integrating itself. Any numbers, constant terms like the 2, we can actually take straight out of the integral and just integrate what's left, which is that. And that's the same as integrating 1 over x squared is x to the minus 2 dx. So we've got 2 times, the x to the minus 2 comes from x to the minus 1. And when we differentiate that, we get, we need to multiply by the reciprocal of -1, which is just 1 over -1, which is just -1. So we're going to multiply by -1. So we've got 2 times -1, which is -2x to the minus 1. So that plus there is actually a minus. Let's just rub that out and put a minus sign in there. So it's minus 2 lots of x to the minus 1. Okay. And then the plus 5 is nice and easy. That is just 5x. Any constant term is just going to be that number times x. And we mustn't forget to put our c on the end. It's worth 1 mark for getting the c on the end. Well, it's worth 1 mark for getting the whole thing right. But if we don't have the c on the end, it's not right. So we lose that mark. Okay, so a fairly straightforward integration with one little tricky part for 4 marks. Question 6. Okay, back to another question with a fraction with a power of x on the bottom. We've got fractional powers, this square root symbol. So this is quite an involved question. We need to write down the value of p and the value of q. So it's essentially it's telling you that you need to break it up into two separate powers of x. So this first one, so we're going to have 6x divided by the square root of x, and the second one we're going to have 3x to the 5 over 2 divided by the square root of x. Now the square root of x is just x to the power of a half, and because it's on the bottom that's minus a half, so we've got 6x times x to the minus a half, and 6x is x to the 1, plus this is 3x to the 5 over 2 times by x to the minus a half. So x to the 1 times x to the minus a half, we just add the powers, so we get x to the half and the 6 in front, and then we've still got the 3 in front of that one, and we've got to add the powers again. So 5 over 2 is 2.5, take away a half is just 2, so that's x squared. So that actually makes it a little bit easier. So those are p's and q's. P is going to be a half, q is going to be equal to 2, and 1 mark for each of those. I think you get it from just getting those two terms anyway. So the next bit, which is worth 5 marks, given that this differential of y is equal to this function we just worked on, and that y equals 90 when x equals 4, so that's telling us we've got to integrate and find the constant term, find y in terms of x, simplify the coefficient of each term. So we want to find y, which is going to be the integral of this thing, 6x plus 3x to the 5 over 2 all over the square root of x dx, which is just the integral of what we found over here, which is a much simpler function to deal with, 6x to the half plus 3x squared dx. Integrating this first one, we add 1 to the power, and that becomes the power of 3 over 2, so half plus 1 is 1.5, which is 3 over 2. We've got 6 times by the reciprocal of this power, which is 2/3. Again, we've got 3 here. This comes, in fact, we don't need 3 there. This comes from x cubed. So we can put the 3 there, but the reciprocal of a cube is 3 is 1/3, and those two are going to cancel out to leave just x cubed plus a constant. So we end up with 6 lots of how much by 2 over 3? Don't know. 6 times. I think I undid it when I went back. 6 times 2 over 3 is the reciprocal of that. So 6 times 2 is 12, divided by 3 is 4. So we've got 4x to the 3 upon 2 plus x cubed plus the constant. Okay, so that's the first section, what we've done. That's pretty well, that's pretty tricky there with some of the fractions. And then we need to do this y equals 90 when x equals 4. So this is what this is. This is y equals this. So y is 90 equals 4 times by x, which is 4 to the power of 3 over 2. And remember, this is a non-calculator paper, so you can't get your calculator to work out these powers. Okay, so what is 4 to the power of 3 over 2? Well, going back to your GCSE indices, 4 to the power of 3 over 2 is 4 to the power of a half cubed. So we separated 3 over 2 into two separate two separate parts. We've got the half and the 3. It's always best to do the fractional part first, because that makes the number smaller, which makes life easier. So we've got 4 to the half, which is the square root of 4. Half is the square root, which is 2. Cubed is 8. Times by the 4 is 32. Plus 4 to the power of 3. Well, 4 times 4 is 16, times 4 is 64. Plus the constant. So we've got 90 equals 96 plus c, which tells me c must be minus 6. And therefore it tells me y equals 4x to the 3 over 2 plus x to the 3, say plus 6, but it's not plus, is it? It's minus. Ooh. Let's use the rubber. Minus 6. Okay, 7 marks in total. Obviously those two is fairly straightforward. This one, you're getting marks for getting the integral. So this bit here gets you 2 marks. Put the numbers in. It's going to be worth 3 marks. 1 for the final answer, and 2 for putting the numbers in correctly with the c term, and 1 for getting out the c is minus 6. Okay. Question 7. Back to a more straightforward 3-step polynomial. So we're going to integrate this. So x to the 5 goes to x to the 6. This looks very familiar to one we did earlier, but the numbers are slightly different. Differentiate this, becomes 6x to the 5. We want 12x to the 5, so we need to multiply that by 2. Minus x to the 4, add 1 to the power. We want minus 8x cubed, so when we multiply this, we've got 4x cubed, so we need to times that by 2. And the 3 just goes to plus 3x. And don't forget to put your constant on the end. 4 very straightforward marks if you know what you're doing. So question 8. So now we've got a curve, has an equation y equals f of x, passes through the point 4, 22. This should be getting very familiar now. We've got a function for the differential, the derivative of f of x, f dashed of x, and we need to integrate that to get back to f of x. And then we need this point to find what the constant value is, and we need to simplify everything. I'm going to show you a different way to what I've been doing so far to get the coefficients of the numbers, not the numbers, of the x terms in the integral. So normally I would just say, look at this, integrate this by increasing this power, then realize when you differentiate this you're going to get 3x squared. You've got 3x squared, so you don't need to put any numbers here. But if we just want to have a technique that just works every time and not have to think about it, if we just put the 3x squared, we've changed it to 3x cubed, whatever this power is here, we need to divide by that power. That gives us the coefficient, and because 3 divided by 3 is 1, they cancel to just leave you x cubed. That's why we just have an x cubed. Okay, the second one, we're going to increase the power by 1. We really shouldn't use 1.5 as a power. We should use 3 over 2, which is the top heavy version of 1.5. Much more useful power to leave, form to leave the power in. And this, if we have the 3 here, which was there originally, and we divide by this power 3 over 2. And then the 7, this is x to the power of 0 because there is no power of x, so we increase that to 1. And we get 7x to the 1, so we divide by 1. We don't really need to do anything there because dividing by 1 just keeps it the same. And we need to add a constant on the end. Now we just need to tidy up this one here. I mean this fraction here, we don't need the 1 there because dividing by 1 doesn't do anything. But this minus 3x 3 over 2 over 3 over 2 looks a bit complicated. But as long as we realise this is a divide, and this is a fraction, so dividing by fractions, the rule for dividing by fractions is to multiply by the reciprocal, which means to turn the fraction upside down. So we multiply by 2/3. When we multiply by 2/3, we times the top by 2, so we've got 3 times 2, which is 6. Then we're dividing it by the bottom, which is 3, so we get minus 6 divided by 3, which is just 2. So in effect, these 3's cancel because one's on the top and one's on the bottom. And we have that as a much neater expression. So we've got y equals x cubed minus 2x to 3 upon 2 minus 7x plus the constant. And this is where the 4 and the 22 come in. It allows us to find this constant. So we put in the values where x is 4 and y is 22. So we have 22 equals 4 cubed minus 2 to the 2 times 4 to the power 3 over 2. Just put a bracket around that. Minus 7 times 4 plus the constant we're trying to find. Now this is why we leave it in the form 3 over 2. It's much easier to work out the power of 3 over 2. But this is a non-calculated question, so we need to know how to do this. 4 to the power of 3 over 2 is the same as 4 to the power of a half. Do the bottom of the fraction first, and then we cube that. And we should know to the power of a half means the square root. So 4 to the square root of 4 is 2, and then we're going to cube that is 8. So this is just 8. So we've got 22 equals 4 cubed, 4 times 4 times 4 is 64, minus, this we decided was 8, times 2 is 16, minus 7 times 4 is 28, plus the constant. So we're taking away 44 from 64, which is 20. So this gives us 22 equals 20 plus the constant, so c equals 2. And therefore y equals x cubed minus 2x to 3 upon 2 minus 7x plus 2. So when you're doing this, you get 1 mark for having all this. You're going to get 1 mark for putting it in the simplest form with the constant. In fact, I think you get 2 marks for that. 1 for this part and 1 for the constant. And then we get 1 mark for putting all the numbers in and 1 mark for getting the c is equal to 2. Okay, next one. Okay, question 9. Back to the simpler version where we just got to integrate. We don't have to find the constant, but we do need to say what there is a constant. So we're just integrating straight off. So the integral of 8x cubed plus 6x to the half minus 5 dx. There's no real need for a bracket here. Integrate each part, so we do. And again, I'm going to do this like I did the last one, where I'm not going to work out the coefficient straight away. I'm just going to do it. Oops. I'm going to just let the numbers take care of themselves. So this is going to the power of 4, so we increase the power by 1 and we divide by that power. So whatever we got increase this to, we divide by that. 6x to the half, we need to increase by 1, becomes 3 over 2, just like in the last question. And we need to divide by 3 over 2. And then we increase the power by 1 on this. This is x to the power of 0. So this becomes x to the power of 1, which is x, divided by 1, is just 5. And we must remember to put the c on the end, otherwise we'll lose a mark. Okay, the only thing we really need to do is this first one's nice and easy. 8 divided by 4 is 2, x to the 4. This is a little bit tricky, so let's do this over here. 6x to 3 upon 2 divided by 3 upon 2. That's the same as 6x to 3 upon 2 times by, because this is divide, we times by the reciprocal, which is 2/3. And 2/3 of 6, we just deal with the numbers. 2/3 of 6, well 1/3 of 6 is 2, so 2/3 is 4. So we end up with 4x to 3 upon 2. So we're adding 4x to 3 upon 2 minus 5x plus a constant, and there we go, 4. Fairly straightforward marks. Okay, question 10. We're given the differential function straight up, dy by dx equals this. This was we're fairly familiar with, or this is a minus sign. This though is a new one to these integration questions I've been going through, but it does come up a couple of times, so it's worth going through in detail. It's a 7-mark question. We've got to find the constant again, so we're given x and y, and we need to find y in its simplest terms. So to find y, we need to integrate 5x to the minus a half plus x root x dx. The reason why it's saying x is greater than 0 is because the square root of x doesn't have any values in the real plane less than 0. So it's just doing that so you don't have any awkward numbers. Okay, so and quite often, I mean most of the time we ignore this for these type of questions, we just get on and do it. So let's do this first part and then we'll worry about this in a minute. So integrating x to the minus a half, we need to add 1 to the power. Minus a half plus 1 is just a half. We got 5 there, and we're going to divide, but I'm going to carry on doing it like this, dividing by, not by minus half, but just by a half, because that's the power that's going to come down. We need to divide by that to get rid of it. And then we need to deal with this, x root x, okay. Now this is testing your more of your understanding of indices rather than integrating, because what we need to change this into a form that we can integrate. So x on its own is x to the power of 1, and x square root of x is x to the power of a half. So when we times two powers, we add them. So this is actually the power of 3 upon 2. So we're integrating x to the 3 upon 2. So we're going to add 1 to the power to make x to the 5 upon 2. And there's no numbers in front of here, so we're just going to divide by that 5 upon 2. And we need to add on the constant. Okay, so when we're dividing by the fraction, we are multiplying by its reciprocal. The reciprocal of a half is just 2, so we're actually just timesing that by 2. So we need 10x to the half. Y equals this, y equals that. This one, we are dividing by 5 over 2, so we need to times by 2/5. So we need to put 2/5 x to the 5 upon 2. And we got our constant. And now we need to use the two values we're given, x and y, so we replace the y with 35, and we replace the x with 4. Oops, replace the x with 4. So 35 equals 10 times 4 to the half plus 2/5 times 4 to the 5 upon 2, which is going to be a little bit tricky, but we'll do that in a second, plus the constant we're trying to find. So 4 to the 5 upon 2, let's deal with that. 4 to the 5 upon 2, that's the same as 4 to the half. So we deal with the bottom of the fraction first, to the power of 5. So when we do a power of a power, we multiply the two powers together, we get 5 over 2. So we can use that to split the powers up. And 4 to the half is just the square root of 4, which is 2, and 2 to the power of 5 is just 2 times 2 times 2 times 2. So cubed is 8, 4 is 16, the power of 5 is 32. So I'm going to take that up to here, and we've got 35 equals 4 to the power of a half is 2, times by 10 is 20, plus 2/5 of this 32, that's what we worked out 4 to the 5 over 2 to be. So we've got 2/5 of 32 plus the constant. So we take the 20 over this side and get 15. This thing here, 2 lots of 32 is 64. 64 over 5. 64, well 5 goes into 60 12 times, 12 and 4/5. So we take away 12 and 4/5 or 12.8, depending on how you like to do it. I prefer fractions, but a lot of people like the decimals. So that's 1/5 makes 13. So it's 2 and 1/5 or 2.2. So our y equals, so again we're going to here, y equals 10x to the half plus 2/5 of x to the 5 upon 2 plus 2 and 1/5. Okay. Question 11. Okay, we've got 4 more to go. Let's try and speed things up a little bit. This is a simple one again, we're just integrating, though finding the constant term is only worth 4 marks. So we integrate 10x to the 4, so that becomes x to the 5. Got the 10, we need to divide by the 5, we divide by this power. This is x to the 1, so that it becomes x squared. So we've got 4x squared over 2, we divide by the 2. And this one, this is a tricky bit, so we've got to do, let's have a look at this separately. So 3 divided by the square root of x. Square root of x is x to the power of a half. When you divide by a power, x to the power of something, that's the same as multiplying by the negative power. So 1 over x to the half is x to the minus a half. So we're actually integrating that. So that becomes, we add 1 to the power, so we get x to the half. We've got the 3 there, we need to divide by the half. So we got 10 divided by 5 is 2, x to the 5. 4 divided by 2 is 2x squared. 3 divided by a half. Dividing by a half is the same as multiplying by its reciprocal, so we multiply by 2 over 1. I'll just multiply by 2, which is 6. So dividing by a half is the same as multiplying by 2, and there's our answer. Oh, and we mustn't forget our constant on the end. We'd always lose a mark if we do that. Okay, nice, straightforward-ish with this interesting power for 4 marks. Question 12, another 4-mark question. So we just got 2 terms this time. First term is our old favourite 3x squared, so we're integrating 3x squared. We didn't know already, it's just x cubed. But if we remember to put the 3, divide by the 3, that's why it's just x cubed. Now this one, 4 over x squared, minus 4 over x squared, that's 4 lots of 1 over x squared, and 1 over x squared is just x to the minus 2. So we've got 4 lots, or minus 4 lots of x to the minus 2. So we've got to integrate that, so we add 1 to the power, so we get x to the minus 1, we've got the minus 4, and we're dividing by this minus 1. So that's actually just going to change the sign. So we end up with x cubed, don't forget a constant, minus 4 divided by 1 is just 4, x to the minus 1 plus a constant. We don't think you can do more than that. You could rewrite this bit here as, if you want to be fancy, you could write it as 4 over x, but that's perfectly fine. All 4 marks. You can only get 1 for, you'll lose a mark if you don't put a C on the end, and we're getting method marks for showing that we know we need to add 1 to the power. We get an answer mark for getting the term in front of the x cubed, and 1 for the 4x to the minus 1, and then 1 for the correct finalized equation. Question 13, it's only worth 3 marks, is probably the simplest one we've done so far. 2 terms, nothing complicated at all. So the first term, integrate x cubed, we get x to the power of 4, power 8 there, divide by this power. This is x to the power of 0, so this becomes x to the power of 1. That's just a 4 in front of that, and don't forget your constant. 8 over 4 is 2, 2x to the 4, plus 4x, plus the constant, 3 marks. Question 14, and the final one for this integration video. Another one of the tricky ones. We've got this x, root x thing reappearing. We've got numbers we've got to substitute in. It's worth 7 marks. But if you've done all the other questions, you should be able to tackle this one and get it completely right. So we've got divide by dx. This x greater than 0 is not important, it's just because of this square root. Can't have any values less than 0, otherwise that's undefined. So we've got to integrate this function, 6x to the minus a half plus x root x. I'll show you that again in case you hadn't looked at the rest of the videos. Okay, so add 1 to the power, minus a half plus 1 is a half. We've got the 6, we need to divide by this power to leave a 6 on the front. And then this x root x, that's the same as x to the power of 1 times x to the power of a half. The square root of x is a half. And when we multiply powers, we just add them. So we get 1.5, but we really should write that as a top-heavy fraction, 3 upon 2. So we've got to try and integrate 3 upon 2, so we add 1 to the power to get 5 upon 2, because we add 2 halves to 3 halves to make 5 halves. And we need to divide by the 5 upon 2, and we need to add on a constant. Okay, so let's just tidy this up. 6 divided by a half, that's the same as multiplying by 2, so that's 12x to the half. Dividing by 5 upon 2 is the same as multiplying by 2 upon 5. And there we have our function for y. Now we need to put in our values. Y is 37 when x is 4. So we've got 12 times 4 to the half plus 2/5 times 4 to the 5 upon 2 plus a constant. Well, 4 to the power of a half is just 2, and 2 12s are, let's actually do this up here. So we've got 37, 2 12s are 24, plus 4 to the power of 5 upon 2. I've done that before, let's just recap. 4 to the power of 5 upon 2, that's the same as 4 to the power of a half do the bottom part of the fraction first, power, and then we do the power of 5, so the 4 to the half is 2, 2 to the power of 5, well 2 cubed is 8, the power of 4 is 16, power of 5 is 32, so we've got 32, 2/5 times 32 plus a constant. Take 24 off this side, we get 13. This is 64 over 5, 2 lots of 32 is 64, plus a constant. 64 over 5 is going to be 12 and 4/5, and we take that away from 13, 12 and 4/5 take away from 13 is 1/5, so the constant is 1/5. So we go back to our equation, y equals 12x to the half plus 2/5 of x to the 5 upon 2 plus 1/5. Okay, we could possibly multiply by 3 to get 5y and just have all whole numbers. We don't need to. Each term is in its simplest form. 7 marks. If you followed all the videos I've done so far, and you can do this one, you pretty much nailed integration of all different types. Okay, if you made it to the end of the videos, well done, and hopefully you'll do well on these questions in the exams. Question 3. Okay, we're stepping up a little bit again. We're doing this slightly different format. We're using functions this time. Instead of y equals, we're doing f of x and f dashed of x. It's the same thing. F of x is just the same as y equals. It's just written a different way. And again, we've got this, similar to question 2, we've got this quotient that we've got to simplify into the 2 square roots. When simplifying surds, we're really thinking about what square numbers go into this number. Now this number is 16 times 2, and 16 is a square number. So that's the same as the square root of 16 times the square root of 2, which is 4 root 2. If we're going to combine them with a plus, this one's going to be based on root 2 as well. So root 18 is 9 times 2, so 9 is a square number. So a lot of these surds questions, well, all these surds